day to all of you out there that have just joined us for this first of our webinar training events for 2021. It is really an honor to welcome all of you to this event. We have been overwhelmed by the positive response that we've had to this webinar invitation. So without further ado, I'm going to start just by outlining, first of all, what we're going to discuss today. And I think the very first question that a lot of you probably have is, how long is this going to take? So this webinar will probably be longer than most of the other ones that we've got planned for this year. We should be done in about 40 to 45 minutes, excluding question time. I'm going to try and do the hands-on JunoViewer things first after we've done the introductory slides, so that if you do want to leave earlier, then you won't miss out on getting some experience with JunoViewer. Okay, so in this webinar, we're going to first of all just do a theoretical recap of the key descriptive statistics that you should be quite familiar with in JunoViewer. And then we're going to immediately go just for some hands-on practice, looking at some of the most often used reports in JunoViewer, and then just discussing the statistics that you are actually looking at in that. We'll come back to PowerPoint towards the end and just explain why graphical representation of data is very important, and you shouldn't only rely on a few numbers like the mean value on a section of road or percentiles, but you should actually be looking at the graphical elements. Then we'll talk a little bit more about distributions, and then I'll just very quickly illustrate some of the things that we've done in JunoViewer in Excel. I think most of you are very familiar with that, so I'm going to do that very quickly, but at least you'll be able to tie the knot between what you're seeing in JunoViewer and what you typically see when you're working in an Excel spreadsheet calculating statistics. And then we'll finish off with a summary and also Q&A. Okay, just some housekeeping points. Please, as we go along, if you can add any questions or comments in your Zoom using the Zoom Q&A feature. Thomas here next to me will try to field those questions if they are very urgent. And if you, obviously, if you get stuck with more than 60 people, we won't be able to actually stop for to help people individually. But if we see, of course, everybody suddenly getting stuck, then we'll stop and see if we can resolve that in time. So just a warning, because you will be doing some hands-on practice, at some point I'm going to ask you to start working in JunoViewer, and you will then also have to follow my demonstration on the screen. So you just need to figure out, maybe while I'm going through the first few slides, how to get your Zoom window and your JunoViewer window side by side. If you've got two screens, that's quite easy. You can drag one onto the other screen. But if you only have one screen on a laptop, you can either split your screens and move one to the one side and one to the other, or you can just get out of full screen mode with Zoom. There's a drop down at the top, and you can exit full screen mode, and then you can just use one on top of the other. So just try to figure that out as we go along, and just be warned that at some stage you will need to do that. If you're asked to follow along in the training account, I want to ask you, if you have your login ready, please log into JunoViewer now and just get that account open so that later on when we start working in JunoViewer, then you are all ready to go. Okay, so let's kick off and look at the why we need to understand descriptive statistics as a foundation for working as an asset engineer. So descriptive statistics are, of course, the key element if you want to compare things on your network. Once you can compare things, then you can start making decisions. So when we are talking about basic descriptive statistics, we often sit with a set of data like what I've demonstrated here. So here we've got a road A, and we are looking at the rut depth numbers here. And then we may have another set of data, let's call it road B, and there's another set of numbers. So descriptive statistics is going to allow us to compare this data. Now, when I consider descriptive statistics, I like to look at it in terms of explaining 4 different dimensions of the data. So first of all, there's the size of the data. And this is simply the number of observations. Of course, if you look at these 2 groups of data, it's quite obvious that one contains more observations than the other. Then we have the shape of the data. Now, the shape of the data is basically just the name that I'd like to use for the distribution of the data. And we're going to look at that in more details right now. The third dimension is the central tendency of the data. So if you are scrolling down your eye through this list over here, you will see that there's quite a few times that your eye starts falling on 8 or a 9 or a 7.5. So in that way, you can quickly start seeing that every data group has some sort of a central tendency. And then there's the range and the variation of the data. So in statistics, this is often called the degree of dispersion in the data. And that includes then, of course, the well-known percentiles, which gives you the value at which a certain percentage is less than that number. Okay, so let's look at that in a bit more detail. Let's say we've got a set of data over here, and this is again the rut depth for a certain road. The very first descriptive statistic is to look at the shape of the distribution. And we do that using the well-known histogram. So basically, we are using our domain knowledge to divide our data into bins. So here I've got 0 to 4 millimeters, 4 to 8, 8 to 12, and so forth. And then simply we go and count the number of observations falling in each bin. So between 0 and 4, I've got a certain number of observations, 4 to 8, 8 to 12, 12 to 16, and so on. Now this graph gives us a good idea of how our data is distributed. And that's what I like to call the shape of the distribution. And so the first thing that you can see is that quite clearly the data is clumped in a certain area. And that is basically what we call the central tendency. Statistically, there are 3 commonly used parameters to define the central tendency. They are the mean. Lots of people would also just refer to it as the average. The median, which is the point at which 50% of your data falls above or below that point. And then the mode is the data point that occurs most often. When you're using real number data, so data with a lot of decimals, very often the mode is not very meaningful. So most commonly we use the mean and the median. So in this case, I've just illustrated, for example, this seems to be like where the central tendency of the data is lying. Then the third dimension, as I noted, was the range and the dispersion of the data. So here we're interested in the minimum and the maximum values, and then the range of the data, which is basically just the maximum minus the minimum. So we can illustrate that in shorthand description here as that range of values over there. Then we've got the standard deviation, which is an indication of how much the data on average varies from the mean. So the standard deviation would simply be calculated by taking this mean value, which you need to pre-calculate, and then you go point by point, and you take that point and you subtract the mean, and you take the square of that, you sum all of it together, and you divide by the number of observations, and then finally you take the square root of that answer. That gives you the standard deviation. The variance is simply the square of the standard deviation. So in engineering terms, we would mostly use the standard deviation because the unit is the same as our data. It will be millimeters, but for the variance, since we are squaring the standard deviation, the unit is no longer the same. The fourth dimension here is the percentiles. So for example, the 90th percentile would be that data point or that number where 90% of the data is below that. Similarly, the 10th percentile would be the point at which 10% of the data is below that point. So we can illustrate that with bars like this. So there you have basically a short dictionary of your descriptive statistics. Now, the reason I often like to start with a histogram is because the shape of the histogram tells you a story about your data in engineering terms. When we first encounter statistics, very often we learn about a symmetrical distribution like this, which approximates a normal distribution. But in pavement engineering and linear asset management, we very often find that the data is right skewed. The reason for that is that we don't have negative values. If this was, for example, rut, so the data cannot march past the 0 point into the negative territory. But of course, the rut can always go higher. And so you are always faced with this situation, or not always, but very often faced with these right skew distributions. When you have a skew distribution like this, your central tendency parameters, the mode, the median, and the mean will no longer be the same. If you have a symmetrical distribution, the mode, the mean, and the median will more or less lie on top of each other, depending on how exactly symmetrical your data is. But in a right skewed distribution, generally speaking, this is not always the case, but generally speaking, your mode, the value that occurs most often, would lie mostly to the left. Then your median would be a little bit to the right. And finally, the mean value is going to be affected by these very high values over here, and that's going to pull the mean even more to the right. You can always also find a left skew distribution. In that case, these central tendency indicators would be the opposite way around. Also important about the histogram is the width of the histogram. So if you have a newly constructed road, you would very often find that if you're looking, for example, at roughness, measured roughness, or rutting, you would have a fairly narrow distribution. But for older roads, you are going to find that your distribution is getting much more wide. And that's important because you can see in this case, the central tendency of these two distributions is the same. But in terms of managing your asset risk, that's where all your risk is going to lie. So if you are doing, for example, deterioration modeling, and you are relying on the average predicted value for every treatment length or every segment on your network, you may be really badly bitten by this group of data that is lying over here that is not being included in your model at all. We hope to get into this territory later on this year with other webinars. So one word about the percentiles in Excel. You'll find there's two formulas for calculating percentiles. The one is the one that's excluding 0 and 1, and the other one includes it. And if you're interested, just go and Google percentiles in Excel X versus Inc. And this site has got a nice example showing the differences between the two. And you can see that for this .exe variant, you can, in some cases, get an error in the formula if you're asking for the percentiles of 1 and 0. Generally, Juno Viewer always agrees with this value, and therefore we would recommend, if you want to check your answers from Juno Viewer in Excel, use this formula or the old variant, which is simply the percentile. Okay, so just putting the concepts together before we go over to Juno Viewer. If we have our typical road situation, we have our measured rut, and obviously that is going to vary spatially across the road length. We take this data as a first step, and we're going to look at the distribution of the data. Once we have the distribution, we can calculate the central tendency, the range of the data, and the required percentiles, depending on what level of risk we are interested in looking at. Now, up to this point, the one dimension that we haven't looked at all is the time dimension, because, of course, in asset management, your data is not just static. You get a new survey of data every year. And so it's very typical to want to look at data from different surveys in a graph like this. But of course, you can't do it in this type of graph because you've got a linear scale here. So a way to look at the whole distribution of data is simply to take this little shorthand description of your distribution, and to take that distribution and to turn it on its side and look at it in that way. So if I go in the next year and I have a new set of data, I can again do the same and I get a new distribution like that. And in that way, as I get more surveys, I can track how this road is performing over time in terms of the central tendency and my percentiles. Now, very often you would find that if you look at other software or statistical reports, you would find that this data is being represented with a box and whiskers plot like this one. And the box and whiskers plot is it's very closely related to what we are showing here. But generally, as a standard, the box and whiskers plot would have a line indicating the median, and then you'd have the 75th percentile and the 25th percentile. And the width of this, or the height of this plot, would then be your interquartile range, because this 25th percentile is one quartile and that's the other quartile, and this is the range between the quartiles. Now in JunoViewer, if you are going to select this bar to be the 25th percentile, or the 75th and the 25th percentile, you basically have the equivalent of a box and whiskers plot. But most often, engineers would want to look at something like an 80th or a 90th percentile for this top range. And that's why we chose to actually have our own shorthand version of the box and whiskers plot in JunoViewer. Okay, so that's enough theory. Let's go to JunoViewer and look at some actual graphs and see how we can put these concepts into practice. So here I'm in my JunoViewer training account. If you have not logged in yet, then please make sure you log in now. And I'm just going to start off by going to the Analyze menu. And I'm going to go to Section Analysis. All right, so I'll just do that slowly for those of you who are having their very first experience in JunoViewer. I go to the Analyze menu. I go down to Section Analysis. All right, so this is a view in JunoViewer that allows you to drill into detail on a specific section on your network and interrogate the data and the patterns that you see on that specific section of road. So what I want you to do is to go and click on the Select Location button and go and select section 003. So that's road 003. And then subsection 0027. Right? So 003 is the section and the subsection is 0027. And then you can see here in JunoViewer, you can select specific lanes to view. But for this example, I want you to just go to the all. So we're selecting data on all lanes. And now we're going to select the subsection of this road. So you can see this road is 18 kilometers long. But we want to focus only on kilometer 14.5 to kilometer 15. Okay. So I'll just pause here for a moment. Please make sure that you've got the same inputs, section 003, subsection 0027, and make sure you enter kilometers, not meters. So that's 14.5 to 15, and then click on OK. Now you'll see in this view, there are several baked in type of reports that we have here. And I want you to go down for now and just select the one second from the bottom. That is the rut mean in the left wheel path. And we're going to look at an analysis of that. So if you click on Generate Report, you should see a graph that looks like this. And this puts together everything that we've just looked at in a very detailed way. So you can see you've got a linear plot here showing how the data varies over time. Now this road overall is not in a fantastic condition with respect to rut depth. But in particular, the linear plot is still useful because it shows you that this specific area linearly is actually where the worst problems on this section is lying. Now for this type of view, JunoViewer will automatically go and show you the last two surveys of data in this view. So you've got a survey in 2018 and a survey in 2019. This graph over here is, of course, then your histogram. And JunoViewer automatically finds the latest survey and shows you a histogram of only the latest survey. Of course, you could put more surveys side by side here, but it gets very messy and difficult to understand the graph. And in any event, this plot over here gives you this shorthand of the distribution over all the years that have been set up for this report. Okay, so this is then a very handy summary. If you click on this cog icon over here, you can modify some things like the font for certain elements of the graph and so on. And you can sort of fine tune what you are seeing in this. And I'll talk a bit later about getting this graph out of JunoViewer and into a report or into Excel. So while we are here, let's just go and look at another section of road. And I want you to just go back to the select location button. And this time I want you to select section 1 and subsection 11. So 001 and then 0011 as the subsection. And then the location to look at is from kilometer 3.5 to kilometer 4. And then you click on OK. Now here you can see a very different type of road response in terms of rutting. Linearly, you can see your data is almost uniformly in the good to very good range for what you would expect for rut depth. And you can immediately see the shape of the distribution for the last survey has got a very different form. It's still a right skewed distribution, but you can see where the central tendency is lying. And what this graph also tells us that this road has performed quite consistent over this last number of years. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9 years of data being shown here at the same time. So for 9 years, I can track that this road has performed quite well. So again, this shorthand statistics is actually what really allows you to very quickly analyze in a fairly sophisticated way how this section of road has performed over time. In my view, better than you would simply get from a scatter plot by plotting 10 years of surveys over one another. You're just going to get a complete mess of different colors and points on a scatter plot like that. All right, so the other type of view that is quite useful and that we use quite a lot in JunoViewer is basically a zoom in of this trend graph. So if you go to the Analyze menu and you go down to Trend Report, so I'm in the Analyze main menu and I go down to Trend Report, then I'm going to select again the rut mean in left wheel path as my parameter that I want to analyze. And I'm going to go and look at that first segment that we looked at. So this is 003, subsection 27. And then the kilometer position is from 14.5 to 15. Okay, so I've got section 003, subsection 0027. I'm selecting all lanes and from kilometer 14.5 to 15, and I click on the OK button. Now, you may see something different initially, depending on how, if it's the first time you're opening JunoViewer. So if you don't see what I'm showing here, just click on this drop down. This is where we choose the type of statistics to show here, and just go and select that you want to see the 90th percentile to the median to the 10th percentile. And then your date range, let's look at the last 15 years. This group by date is just for if the surveys vary in time. For example, you go down the road in one direction one day and you come down the road in the other direction on the other day, then you don't want to plot that as two different surveys. So JunoViewer would automatically group anything within 90 days as one single survey. Okay, so when you've selected all of that, you can click on the refresh button. And you should now have something that's very similar to what I'm showing here. So let's analyze this a little bit. First of all, you can see that overall this road is a bit of a stinker in terms of rut performance. For at least 1, 2, 3, 4, 5, 6, 7 years, it's had a 90th percentile rut in the left wheel path higher than 20 millimeters. Also, you can see from this that the road was probably rehabilitated or something was done at this point, because you can see that the distribution of the data had significantly fallen. And from the central tendency here, which is basically your median value, you can see that that has reduced from 12 to 4.5. And the 90th percentile value, the top bar, has gone down from 20 to 8.1. Now you'll see that after this money was spent to improve this road in about 4 years, it was back to where it was in the beginning. Definitely at 5 years, it was worse than it was before this rehabilitation. Now, JunoViewer, if you have routine maintenance data in your database, you can talk to the JunoViewer support team, and they can wire up your routine maintenance table so that you can overlay routine maintenance data on this graph. So I've done that for this training account. So if I go here to overlay maintenance data and I switch that on, now I can see where maintenance has been done, or at what times maintenance has been done on this road. Now, if you are used to the type of codes that are used in New Zealand for logging routine maintenance, then you would very quickly see that we're doing a lot of water blasting here, so improving skid resistance. But over here, there's a stabilization. So that's probably something that was done on this road, and that had a small impact on the distribution of the data. Again, you can see some stabilization there and there, but you can see over time, this road has attracted quite a significant amount of maintenance costs. And so historically, you can see that this road has shown a very familiar pattern where the rutting initially has increased very quickly, and then slowly it starts to drop down over time, and then at some point it starts to kick up again. And this may be actually at the point where water is getting into the road. And if you look at the maintenance, you'll see that actually it's starting to have potholes at this time here. And I think also some crack sealing I noted in this bunch of data maintenance that was done here. Let's go and look at the other road that we looked at earlier and see how that performed over time. So if we go to the segment again, and we go and choose now the other segment, which is section 001, subsection 0011, and we are looking at 3.5, kilometer 3.5 to kilometer 4. If I click on OK, now we can see a very different pattern of behavior on this road. We can see also sometime in the past, this road did have quite a high rut. You can see it deteriorated quite rapidly, both in terms of the 90th percentile and also in terms of the central tendency over here, shown with the red dot. Some work was then done at that point, probably not only this maintenance that is being shown here, but maybe some form of rehabilitation. There was also a reseal done over here. And this work was quite effective in bringing this rut depth down. So you can see that your distribution of data, again, remember, this is basically just shorthand for a histogram turned on its side. And you can see that that has reduced the central tendency and the 90th percentile. But probably most important from an asset planning point of view, it has done that effectively so that this has remained constant over time. So since 2011, this road has really, number one, not attracted too much maintenance, and number two, the distribution of rut has remained quite similar. If you have a road like this and you're looking at the maintenance and you want to see in more detail what this maintenance entails, then you can always go back to the the section plot that we showed earlier. So under the Analyze menu, I go to Section Analysis, and I'm going to just select that road that had a lot of maintenance. So that was 003, and then 27. All lanes, but in this case, I'm not going to focus only on kilometer 14.5 to 15. I'm just going to show the whole 18 kilometers, and we'll look at the data. So here we've got a breakdown of crashes, accidents on this road, showing us the crashes at different times. You can see this is actually reduced here. I can see wet versus dry crashes, the different light conditions. So basically an analysis of the different crashes and their categorization. Then also you can look at the maintenance analysis in this graph. So I just select the second one from the top. This is now routine maintenance, and I click on Generate Report. And here I can see the cost of maintenance over time, and then also the type of maintenance and what it did as cost. So you can see on this section of road, stabilization has attracted most of the cost. This shows you the number of times that you went out to maintain this road. And then this again shows the type of maintenance and the number of times that you went out. So in this case, we can see for this road, stabilization has cost the most, but pothole filling was the most incidences that occurred, as you would expect. Okay, so now what I want to do is just go and just very quickly look at statistics in Excel. So if you can just follow along with me, I want you to go to the Manage menu item and go to Upload, Download Data. And then you'll find there's a file there that says Stats Foundation Examples. So if you click on that and then click on Download Selected File, that spreadsheet will be downloaded to your computer. And just wait until it stops flashing. And then if you click on that, what I've tried to do here is just to basically show you the Excel way of analyzing data. This is the last survey of data on that road that had the high rutting. And I'm just illustrating here typically how you can lay out your statistic to look at those different dimensions of your data. So I've got my central tendency indicators over here, and these are just the normal Excel formula. My dispersion indicators, standard deviation, variance, minimum, maximum, and range, and then my percentiles over here. Over here, I've got my histogram, and I always take care to make sure that I convert the number of observations to percentage of observations so that I can compare histograms independent of the number of observations in the set. Now, I think for 99% of you that have joined us for this webinar, you would be very familiar with how to do all of these calculations in Excel. But I've learned from experience, there's quite a few engineers that don't know how to generate a histogram like this in Excel very quickly. So I'm just going to very quickly demonstrate that. You can see if I click on my histogram here, that it is using the ranges of this data over here. Now what I'm going to do is just go in here and I'm going to delete this data. And of course my histogram is now empty. Now Excel's got a built-in formula called a frequency, and that is what is known as an array formula. So you have to select a whole group of data to apply that formula. So I'm simply selecting my data over here, and I'm typing equals frequency, and then I can just type tab to compute it, to complete that formula. And you see it asks me for a data array and a bins array. And now the data, of course, is my RUT data that's over here. So I can just go with my mouse and select that data. And now I put a comma, And then my bins array is the next element, and that is over here. These are my different bins. And I close the brackets. And now, very important, before I press enter, since this is an array formula, I have to enter it by holding down Control Shift and then pressing enter. So I hold down my Control and Shift keys and I press enter, and there instantly all of my counts, number of observations in each bin is counted. So now I can just convert that to a percentage by dividing this count by the number of observations down here. And of course, I want to fix that formula so I can copy it down. And there I've got my histogram back. So if I go back to Juno Viewer, and I go back to the report that I showed right in the beginning in my section analysis. I'll just do this quickly. I don't expect you to follow along. I've got 14.5 to 15. And I've got this report over here. And I just right click on this report and I say copy image. I go to Excel and I'm just going to paste it in here. And if you compare these statistics over here, for example, here, the very last survey, I've got 8.9 as a 10th percentile going up to 31. And you can see that's exactly what Excel calculated for this same set of data. The histogram is looking a bit different. And the reason is that my bins over here are different. But if I use these same bin ranges, 0 to 4, 4 to 8, and so on, I can just go and change it here, and Excel will do the rest for me. So I just take that and I drag it down. And now you can see I've got the same histogram. I've got 2 bars at 10%, 1 bar at 24%, and so forth. Okay, so that's quite a whirlwind tour through descriptive statistics. A lot of universities would probably spend quite a few lectures on everything here, and that doesn't include JunoViewer. So if you're still following along, congratulations. I just want to go back before we conclude to show just a few more things. As I said in the introduction, it's important to understand why graphical representation of data is important when you're looking at data statistically. A while ago, there was a statistician called Anscombe, and he created 4 sets of data. If you Google Anscombe's quartet, you go to Wikipedia page, you find more information about this. But what I've done is to just illustrate this in 4 different dimensions, or using a typical road context to illustrate these 4 sets of data. So I've got road A, road B, C, and D. So there's my quartet of data. And what I've done is to just name these, instead of X and Y, I've just given it typical road context by calling this age and this rut. And so you can see that the numbers in these 4 sets are different. But if you look at the mean values, you can see that they are all the same. The variance of the data is also all the same. And actually, you can calculate this not only for rut, but also for age. And you'll see they'll give you exactly the same answers. And even if you're going to do a regression, a correlation between these 2 groups, you'd find that all of them give you the same slope between age and rut, and the same R-squared, or coefficient of determination. So if you're only looking at your data in a spreadsheet as numbers, so you've got one section and another section, you may be inclined to think that these 4 sections deserve exactly the same type of treatment or the same priority, because your numerical statistics all look the same. However, when you look at the data graphically, you can see this is our first of the 4 data sets, road A. And then if you go and look at road B, the data looks like that. So obviously, it tells a different story in terms of how this road is performing. Then the road C gives again another picture, and road D, again, a very different picture. Obviously, in these last 2 cases, there's some sort of an anomaly or a measurement error involved. But again, if you just look at the numbers, you will draw the same conclusion for all 4 of these data sets. So I really encourage you, when you are looking at your model outputs, when you're validating models, use JunoViewer's forecasting view to drill down on each treatment that your model is predicting. Go and look at the graphs. It's really easy. You select the treatment length or the modeling segment, and you can instantly go back into the historical data and see what the actual observed pattern of information is for that section of road. Finally, the distribution of the data actually tells a story. If you're looking at this, these 2 sections of road and their historical performance over time, if you're only looking at the last one of these distributions, you'll see that our upper percentile is basically identical. But in this case, the entire distribution has moved upwards, where in this case, the central tendency has remained the same, but the 90th percentile or the upper percentile has grown. So this indicates that this road as a whole, or this may even be a plot for your entire network, or a subset of your network. It indicates that overall it has increased over time, the entire distribution, whereas this one, your central tendency has remained the same, but the tail of the distribution has moved more and more towards the right. So this would be more indicative of a road where you've got a few bad patches, and those bad patches are growing worse and worse every year and spreading out just a little, whereas the one on the left, the entire road is systematically probably flawed and slowly not being able to accommodate the traffic that you have on it. So that concludes this first webinar. I would just like to invite you, if you've got any feedback or suggestions on this webinar, please send that to us in email. Give us your feedback. We really welcome and appreciate that, especially if it's good feedback or constructive feedback, but also any other recommendations about how did you find the length of the webinar? Is it too long or too short? If there are other specific topics that you'd like us to cover, and also any other suggestions for what we can do to improve in this webinar series. So thanks again, goodbye, and have a great night or day, depending where you are in the world.